All good. Today's topic, can you see on the board? What topic we are going to do today? Laws of motion. Again, one of the very fundamental of mechanics, also known as particle dynamics. That topic we are going to do today. How many of you know basics of it? First thing that we are going to do in this chapter is regarding the force. The entire chapter, laws of motion, is going to tell you an idea about the forces only. Complete force. You can say this chapter is simply a chapter named force. But force is a very complex quantity and it cannot be described in one definition. Many things are coming. What is the significance? Why we need a force? How to measure the force? What nature of force is there? What are the other parameter characteristics regarding a force? So for this one quantity, one force, Newton actually gave us the three laws. All three laws combinedly telling us, measuring, significance, everything, nature about one quantity only, and that quantity is force. So that quantity we are going to discuss. So first of all, see this definition, and if you want to add something to it, type in the chat box. I want to know your knowledge according to your opinion what force is. But general definition of force is, it is the push or pull. It is a push or pull on a body that changes or tries to change velocity of the body. Means force is there to change the velocity. That's point I am saying here. Suppose this is a block and that block is at rest, right? And this is a block. This block is moving and its velocity is constant. Its velocity is constant. In this, it is in uniform motion. Uniform motion. Now what we are doing? We are pushing it. See the sense direction of force. I am applying this force, pushing it, or I am pulling it. These two forces, they will change the velocity. What is the velocity here? 0. That will not be 0. Now, after application of force, velocity will change. After application of force, this velocity will not be constant. This force will change the velocity. Change the velocity. So that is the very basic definition I am taking. There are many things to add into this, but very basic definition. Force is a push or pull that will change the velocity. And do remember, when we are talking about velocity, what is this? That is a vector. I'm not telling speed here. Please don't misjudge velocity with speed. Here we are talking about velocity vector. It will have magnitude. We all know vector we have done. And also it will have direction. So magnitude is there and direction is there. Means what force will change? Force can change magnitude. Force can change direction, or force can change both. So what force is changing? Force changes, or it tries to change what? First, it can change magnitude of velocity, only magnitude of velocity. It can change direction of velocity, or it can change both magnitude and direction, right? Both magnitude and direction. Now your job is, you will tell me, all of you, I will look at the chat box. You will tell me one example for all of them. One example. Tell me one example in which force is only changing the magnitude of velocity. Second example, write A. When you are saying for A, write like this, option A, then tell me an example. Then option B, tell me an example in which force is changing direction of velocity only. And then tell me an example where force is changing both magnitude and direction. It's all yours. Okay, 1 minute I am giving. Write for example of everyone. F equal to ma, yes, Sushila Devi, that is coming in the message. That is for constant mass only, when particles mass is constant. We will discuss everything. You focus on the example first. Tell me the example. No, that shape and position, that will be other part of force, like effect of force in twist or in torque. That is simple particle dynamics we are discussing. Acceleration is coming in both. Magnitude of velocity change, that is also, here also acceleration will come. Here also acceleration will come, and here also acceleration will come. So acceleration is coming by changing the magnitude, by changing the direction, or changing the both magnitude and direction. I am drawing the example, everyone. See, I am drawing the example. You tell me which option is there. You will tell which option. First, here is the block. On this block, a force is being applied and this force is changing. What is being changed here? Magnitude is being changed. It was moving, let's say earlier it was moving with U. Now it is moving with V. This is example of which case? What is being changed? Magnitude changed, direction changed, both changed. What is being changed? This is A. Magnitude. Okay, right. B part, let's say uniform circular motion. Uniform circular motion. Take what example is that? Understand, try to imagine force in your mind. What force is capable of doing? Uniform circular motion. In uniform circular motion, what happens is circular motion is there. The motion is on circular trajectory, but in circular trajectory, speed is not changing. Here is V, here is V, here is V, here is V. Now, can you detect that this is example of B? What force is doing? Here, force is only changing the direction, and that force is called centripetal force, that we will discuss later, right? Okay. And in third case, in C example, if we will talk about non-uniform circular motion, non-uniform circular motion, what happens here? This is the non-uniform circular motion. Here speed is V1, here speed is, let's say, V2, then speed is V3. So speed is changing, direction is already changing. In circular motion, direction, every point is changing, but speed is also changing. So that is the example C. This is example of C. So what happens? What force is capable of doing? Force can change velocity completely, direction wise, magnitude wise, or both wise. I hope that you have understood the basic definition of force. Why we need force? We need force to change velocity, momentum, direction, magnitude, everything. Okay. Now, one more thing, see here. If you want to categorize force, if you want to take the types of forces, okay, there are many types. Like, you just start telling naming and so many forces you will see. But generally we categorize forces into 4 categories. Again, those 4 categories will have the subcategories. So 4 categories I am taking. Rising speed of a vehicle. Yes, that is the magnitude. Speed means magnitude of velocity. And riding in circular path, right, rest, okay, Venkat, Shri, Kumari, Kola, right all. But same thing you are saying, you are saying speed, I am saying magnitude of velocity, both are the same thing. Finally, types, see these types. First force we will take, field forces, what here I am writing basically, gravitational force. Do remember and make a note out of it, everyone, don't miss out this. That is a fact-based question, data-based question that is being asked. In most of the time, we are missing out data and fact-based. Numericals, with so much practice, you will get an idea about. But fact is a fact. Either you know or you don't know. So you, in fact-based question, theoretical question, be extra cautious, right? Types of forces, gravitational. What I was talking about, I was saying this is the weakest force. Weakest force. And that is taken as the reference of forces also. Means the least weak force, that is the, if some force is there, that is a strong force or weak force, that is being compared by the comparing it with gravity. So gravity is the weakest force, right? If some force is other force, how strong is that? That is the reference gravity who will tell how strong is other forces. So first force is the gravitational force. Second force is the weak force. Do remember, weak forces are gravitational force multiplied by 10 raised to power 25. That is the order of weak force. This order, this data, again as I said, no, either we know or we don't know. So this you cannot think of. As a fact base, get ready of the fact, get aware of the facts. Weak forces, gravitational force is the reference. Weak forces or gravitational force into 10 raised to power 25. Make note out of it. Third force I am taking as electromagnetic force. This electromagnetic force, again that is gravitational force into 10 raised to power 36 times, and fourth I will take after electromagnetic. If I am taking suppose strong forces, what I am taking bachcha log? Strong forces. That strong force will be gravitational force into 10 raised to power 38. Got this? So this fact you have to remember, this data you make a note out of it. 4 range of forces, 4 category of forces I have taken. As I said, these all will have subcategories after this. Now in you want Insta ID. You can take my Insta ID also, but this Newton's laws of motion ID is very important. No, Insta ID later you can take. You're waiting for all these classes to take Insta ID, and take my Insta ID after this, okay? But first do this. My question to all of you is one very simple question. You've written the data, okay? Written the data. Now tell me, listen to the question properly. Out of these 4 forces, which forces are short ranged, which forces are long ranged? That is my question to all of you. How beautifully you have noticed these 4 forces, that will be decided according to this. Out of these 4 forces, have a list of this: gravitational, weak, electromagnetic and strong. Out of these, which forces are short range, which forces are long range? Okay, tell me short range and long range. Nikhil, which forces? Gravitational and weak, what? Long or short? What are you saying? I'm not explained anything, just told a fact here. The 4 types of forces are there, that is the range given. Weakest force is gravitational, that is taken as reference. The rest forces have this order of magnitude. 10 raised to over 25 times gravitational, any force is there, that will be categorized into weak force. Electromagnetic forces are in 10 raised to about 36 times the gravitational. That is how it comes. Now, chalo, I am not getting any answer. One strong force, short range. Very good here. Strong forces, short range. But weak force is also short range. Strong and weak forces are short range. Okay. This weak force, short range. And this strong force is short range. And these 2 forces, gravitational and electromagnetic, that is longer range. These are the fact beta. This, as I am repeating, this you have to know, you cannot think out of it. You cannot suddenly think, okay, this will be short or this will be long. That fact base you have to know. So that's the basic definition we did about force. Let's summarize this slide. Force is a push or pull on a body that changes or tries to change. If inertia is very high, it will not be able to change. That tries to change the velocity of a body. When we talk about velocity, we will keep in mind we are talking about a vector quantity. That velocity is a vector. That vector will have magnitude. That vector will have direction. What force changes? It changes velocity. What does that mean? It changes magnitude of velocity, direction of velocity. Both magnitude and direction it can change. Those examples we have taken for this. Then I told you types of forces. For those types of forces, gravitational force is the weakest of the forces. That is taken as reference for measuring the forces. All other forces, order of magnitude is given. And short range, weak and strong, both forces are short range. And gravitational, electromagnetic, those are large range. You don't need 10 raised to power minus 10 or minus 5 meter of distance to have electromagnetic force. You can have a 10 meter or 20 meter. That is also the large range forces. Like wires are going and electric field magnet. Some depends on magnetic field strength also, or electric field strength also. Some like a very strong magnet can pull you or attract some other magnet with a very large distance. So it is large range. You don't need micrometer distance or angstrom distance to have those forces only. Got this? Now coming to the next slide. That slide is okay. Read what is written here. We will elaborate that discussion again. Anti-40 doubts and explain once again. Once again. What is once again? Explain. That is the 4 times explained, and you can see the video. If any doubt is there, you tell me. And every one of you fill up the form there. Description box, fill up the form. Come meet us. Okay, form must be filled, right? Take some time up and fill those form in description box. Be part of STAR program. Now see this, Newton's first law. You must have heard about this law. You must have heard Newton's first law. You found it very easy. But do you know it was not Newton's original idea? It was not Newton's law. How many of you can tell me whose law it was? I can see my rockstar crowd here. Whose law it was and what Newton did to it? Whose law was it? It was not Newton's original law. Newton's only included some of the ideas, some of the modification. This law was law of Galileo. Law of inertia was law of Galileo. Got this? So Newton's first law we say, because Newton wrote this in that format or inclusion and everything. Actually, Newton was the approver for that law of inertia. So first is, this was actually Galileo's law. Law of inertia was Galileo law, and what Newton added to it, I'm going to explain. But before that, we will see what is the Newton first law. We all know that if we have an object, like this is your football, you are standing here. This football is quite bigger in size, but just include, imagine it is less or your size is more here. This football, and it is placed on earth. Where is the football placed? Earth. What is state of motion for the earth? Earth is static. What is earth, Bittu? Earth is static, at rest. And as of now, football is also static. So both are at rest. Now football is waiting some external force to kick it, and then it will be in motion. Don't kick earth. Earth inertia is very high. Don't think you will kick earth. Earth will be in motion. That is infinite inertia. We will come to inertia. But right now understand this law first. You are kicking the football here and football start moving. Football start moving. And according to law of inertia, that was actually the discovery, or you can say discussion, of Galileo. If a body is at rest, it wants to be at rest because of its inertia, obviously. And if a body is in motion, my dear students, it has to be in motion, right? It will be in motion. Then why further at some point football stops again? Football stops again. Why it stops again? Obviously, you know, football stops because of air drag, because of friction provided by the ground. So football stopped because of forces, that is the air drag, or that is the friction applied by the ground. These forces, this friction by the ground and this gravity acting on it, these forces were included by Newton. And the law that it will keep moving with the uniform pace, that was Galileo. When you will combine these two, law of inertia and modifications by Newton, then it becomes Newton's first law. Got this? So again, understand what Galileo said. He said, inertia helps the body to maintain its state of motion, means, or rest. Body is at rest, it will remain at rest because of its inertia. Body is in uniform motion, it will remain in uniform motion on a line because of its inertia. Galileo law ends here. Then Newton said, inertia will maintain the rest, inertia will maintain the motion, but only up to the time when external force is acting on it. If external force starts acting on the body, then inertia will be opposed. Then inertia may not be able to maintain the same state of motion. So external force inclusion was Newton's discovery, inertia was Galileo's discovery, right? Or laws. So what Newton included, to understand it this way. First we have to understand inertia and the two parts, inertia, what it does, and then external force, what it does. You have to understand these two combination to understand Newton's first law. Inertia you will understand, then this is the all description as I said by Galileo, and external force, what it does to it, that was the Newton's inclusion, right? So inertia is what? It's a property that we know. It is a property that maintains state of rest or motion, any motion, whatever motion it is uniform motion will be there in any direction, state of rest or motion, and that motion has to be, I'm writing here, uniform for a body. So that is the inertia. And in general, if particle dynamics we talk about, translatory motion we talk about, that amount of inertia is measured by the mass you have. not shape, not size, only thing that measures for particles, for translatory motion. Again, rotation will have the different measurement, but more normal particle system, translatory motion, the inertia is measured by mass, right? So you have the mass, what mass, and other body have the same amount of mass, so your shape and size does not affect the inertia. Same mass will have the same inertia. So that is measured, you can say, who measures it? Measured by, it is a property. Try to understand, inertia is not a physical quantity. Inertia does not have a unit, inertia does not have a dimension, inertia is a property. But if you want to measure this property, how high or how less is that, that measurement is being done by, measured by mass, which is a physical quantity, all of us know, that is the kg, or that is the dimension, you can write m. So this physical quantity is helping us in measuring the amount of inertia. Okay, so that was the inertia part and Galileo's part. Then Newton comes. Newton says, okay, inertia maintains it, but it can only maintain up to the time force is not acting. If force starts acting, inertia will be opposed. So what is external force? External force opposes inertia and changes the state of motion. Changes the state of motion. Okay, and if external force is zero, try to understand Newton's first law. Newton's first law is dealing with no external force. If you say, why I am saying this, you say Newton's first law is also called law of inertia. So basically in this law you are talking about inertia. Inertia is relevant. Inertia is not changing the motion, not changing the rest, unless external force is acting on it. So when you talk about Newton's first law in any question, try to understand the imagine a state where no external force is acting on the body. With no external force is acting on the body, then you are dealing with Newton's first law. And if external force acts on a body, inertia changes, then that external force will accelerate it. That goes to Newton's second law. Got this? So opposes inertia, changes the state of motion. If external force is zero, then inertia is not opposed. Inertia is not opposed. So that is the basics. We will do some questions also. Basic of Newton's first law we have done. Now it's your turn. Anything you want, ask me. More than welcome to ask. Then we will solve some questions on this also. So ready, my rockstar crowd? See this? Okay. Now I'm opening the chat box. Okay. So you understood the combination of Newton and Galileo. One was telling inertia, one was telling the external force concept to this. That is old Newton's first law. Once again is so common now, after so much discussion, everything once again. Don't ask where is the problem, what technical problem is there, you want force, you want inertia. Just one line once again. Here some few persons are very disturbed when college will open. Babu, you will be notified whenever it will open, right? Don't take tension, that is not in your hand. Like, you take tension about physics. Object at rest remains at rest, motion remains in uniform motion, constant velocity unless, yes, that is right. Okay. Now understand, I am summarizing this slide. So no genuine doubts are coming. External force, of course, we will do, but external force we will mainly do here. I am telling you external force, but mainly we will discuss external force in second law, but briefly I will tell you here. So I am explaining, summarizing this slide, Newton's first law. Understand the topic which is going currently. Many things are in future topic. That I will discuss right now, nothing will be cleared. So our observation should be Newton's first law. So what is this? In Newton's first law, we will think two things. We will think inertia and external force. Someone has asked me external force. External force is that force which is acting on a system from outside. So you have to decide the system first. Who is the system? Decision is again a different topic completely, entirely, right? So you have to understand external force, like I am the system. So whatever force I will apply, that is not external. Whatever is being applied on me, that is called external. Like gravity. Who is applying gravity on me? My gravity is not my force. No. Who is applying gravity on me? Earth is applying gravity on me. So gravity on me is the external force. or some pull or some push. These are the external force. Some force what I am applying, that is called internal. System force is internal, and somebody from outside applying is called external. Right now I can tell you like this, and more elaborated manner we will discuss in Newton's second law. In this, one summary, understand Newton's first law. Newton's first law, 3 points keep in mind. First, Galileo explanation about inertia. It is a property of a body. Every body, every mass, every particle has a property. That property that helps the body to maintain its state of, like suppose I am coming, I want to push you, but I am not able to push you. Why? Because of your inertia. So your inertia helped you to maintain the state of rest. Okay. Suppose my force is heavy. You in your house, you want to push the wall in your house. You will not be able to push the wall. Why not? Because wall inertia is so high. So inertia of wall is helping the wall to maintain the state of rest. Inertia is a property that every object will have, right? Now the point is how to measure inertia. So inertia can be measured by a physical quantity that I called mass. Do remember here, shape size does not matter. What does matter, how much mass is there. The same mass is in a smaller body or larger body will have the same amount of inertia. Then come to types of inertia. There are 3 types. Inertia of rest, first will be inertia which is helping the body to maintain rest, that is called inertia of rest, that all of you have studied in lower class. Second part is inertia of motion, means inertia is helping to maintain the constant motion. And third, inertia of direction. Inertia is also helping the body to maintain its own direction. Inertia of direction. If you want to change any of these 3, you need external force. That was the inclusion of Newton. Now what external force? As I told you, it is just a force which is acting on a particle, on a body from outside. What this external force is up to, what it wants to do, external force wants to change the inertia. Either it will change the rest, or it will change the motion, or it will change the direction. That is the external force tends to do. Okay, more about external force slowly. Newton's have 3 laws. In first law, if you want to get entire force and everything, that is not possible. Newton himself needed 3 laws to explain force. So everything regarding force in one law is not okay, right? Just first law we will understand. Now on that basis, I'm going to check you guys with some of the questions. Be ready with pen, paper and mind also. Solve this. See this question everyone and solve. I'm reading this question for you. A particle is in straight line motion. This is the particle, and that particle is in straight line motion. Uniform velocity. Its velocity is constant. This is the particle. Particle is in straight line motion with uniform velocity. Force is not required to. Force is not required to. 3. Rockstar here. Good. Nice. Appreciate all of you who is actually into physics and attempting questions. This is the first sign of student. If this intent is very much is there, very good here. Appreciate all of you. So force is not required. Force is not required, and not required means you don't need a force. You don't need a force if you don't want to change the inertia. When you want the force, when you want to change the inertia, so you don't want to change the inertia, means you don't want to change. See in the previous slide, you don't want to change inertia, means you don't want to change rest. You don't want to change motion. You don't want to change direction. These 3 you don't want to change. You don't need force. But here body is already moving. Body is already moving. There is no question of rest. So if you want to keep the same speed means inertia of motion. Inertia of motion. Inertia is helping to maintaining the same speed. No, beta. Who is helping the body to maintain the same speed? Inertia. You want to oppose it? No. Then why I am saying no? Not required. Force not required means inertia change is not required. It means inertia of motion to keep the speed same. If you will change the direction, you need force. Force needed. And question says force not needed. So which option is there? Third option. Many of you just saw the question and answered it beautifully. Good. Keep it up. Got this question, everyone? Can I go to the next one? Can I go to the next one? Good. Okay. This one. Start. Read the question and answer. You are traveling on an aeroplane ले लो, at constant speed of 650 mile per hour. Okay, 650. So you are moving on aeroplane with 650, that is the speed, and your friend is traveling in his car at constant speed of 60. There are two speeds given. Who experiences a larger acceleration? Here also written constant speed. So if speed is constant, it means you are not applying any force, no baba. Speed is constant, inertia of motion is not being changed. You are not applying any force. Speed constant means force is zero, because force will act, force will change the speed, and force zero, then acceleration zero, because acceleration is force by mass. Mass to will not be zero, neither car will be massless, nor the aeroplane will be massless. So mass is not zero, acceleration is zero, so force is zero here. Understood? So constant speed means zero acceleration. Whenever I will ask you out of these two, you will answer one that is not necessary. Answer conceptually. You should have answered, sir, both speed has constant, so nobody will have acceleration. Okay, larger or smaller is the out of question. No acceleration there. Understood, Andy? Got this? This is called trap question. Many of you fell in the trap. I don't know why. Little distraction. Okay, ready with this? Any doubt in this question? So I'm opening the chat. Tell me any doubt, any clarification you want. Otherwise, we will go on next slide. Yes, Andy? Ask me also, how are you, sir? You are asking, talking to each other, how are you, this, how. You don't want to ask, how am I? No doubt, no doubt. Okay. So ask once, how are you, sir? What is meaning of short range and long range? Short range and long range. Long range means in meter, kilometer and light year, that is long range. Short range means in angstrom level, very small subatomic level, that is quantum physics level. There if forces are there, that is the short range forces. Okay, I'm good. Thank you for asking here. But I'm asking you to ask, then you are asking. Otherwise, you are busy in yourself. How are you? Yes. Even if I will not present on Sunday, you tell me, I will come on Sunday to meet you. Don't worry. Okay? Chalo. Next, I am good. Thank you for asking. Suddenly you have realized you have to ask sir also, no? Good. Now come to this. We are going on next one, momentum. That will give you an idea about Newton's second law. But before ending Newton's first law, I want to test all of you with one question. Newton's first law, final question. Got it? Don't do mistake in this question, any one of you. Full focus on the question. Okay? See this. One question I am asking from my side here, Newton's first law, ending question. Suppose this is a row and this is a block. Okay? And there is one more block here. This point, let's say leveling as A, that point is B, that point is C, and that point is D. Right? A force is applied, a force is exerted, applied at D point. Which point we are applying the force? At point D. First, slowly, and then with an impulse, means with a jerk. Point D, I am applying the force, first slowly, then with a jerk. In both the cases, find the point from where string will be broken or may be broken. Okay, I'm elaborating this question. I want you to answer it right. What I'm saying I'm applying force at point D. At this point, we are applying the force, right? But I'm applying the force slowly. I'm simply gently applying the force. And then in second case, I will apply the force with a jerk. I will hold it and I will apply force with a very fast rate, right? High impulse. In both the cases, when I was applying slow and when I was applying fast jerk, then from which point a string might be broken? Where is the probability? First case, tell me the answer for slow case, everyone. Right, this way you will write, I will not be able to judge the answer. I am applying slow force. Which point could be the point, breaking point? Slow force I am applying, which point? Slow. Okay, Gautam is saying A, Balu is saying C, then A. Someone is saying B also, okay. So slow force when we are applying, then point of breaking will be A, and force with a jerk if I am applying, then the point of breaking will be C. Now try to understand Newton's first law here, inertia and all. Understand elaboration, all of you. I am applying slow force. Slow force I am applying, force is slowly getting transferred. M has all the time to take the force and then force will go to A. Means inertia will change for CD, inertia will change for M, and that it will change for AB. Because I am applying force very slowly, the force will be transferred to the entire system and up to A it will be transferred. Of course, after is the ceiling, that is a massive body. So from A it will be break. Force has got the time to transfer to the entire system here. Got this? But when you are applying force with a jerk, in second part, force with a jerk, in jerk what happens? CD will come into motion. I am explaining second part. You are applying force with a jerk. So force you have applied at D. D to C is one body. So CD will come into motion. But rest of the body didn't get the time to get the force. Because you have applied force very quickly, that force will go applied on CD. And beyond this body is still at rest and this body come into motion. The point from where rest and motion are separated, that is called the breaking point. If I want to break this stylus or marker, I will hold this one part, half part I have made static, and second part I will take and I will move it, then it will be broken from here. So what is the breaking point concept? Breaking point is that point at which, across which you can say rest and motion are separated. One part is at rest, second point is in motion. Anything you want to break. You are breaking a thread also. You are putting some portion of thread under your teeth and then you are breaking it. So the portion underneath here, under the teeth, that is at rest, and rest of the portion of thread is in motion because of your hand. So wherever across which point rest and motion are being separated, that point is called breaking point. I hope you got this breaking point concept. So if question is asking, Babu, where is the breaking point? See if at which point motion and rest are being separated. So in slow, when you are applying slow, entire body will have one state of motion and at A it will be broken. When you are applying with the jerk, only that will come into motion, rest of the body will be at rest. Rest and motion are being separated at C point. C will be the breaking point. I hope you got this. Breaking point concept, have you got, everyone? What is breaking point? Breaking point is that point across which motion and rest of the body are separated. One part is in rest, one part is in motion. So whenever question will ask you this breaking point, just the point across which motion and rest are being separated. Now come to this concept. That concept is the basic concept for your next topic, that is next law, which is called Newton's second law. But before going to this, we will discuss momentum, and I have written one definition for you. What is momentum? Amount of motion stored in a body is called momentum. Means whenever you are running and whenever you have motion, suppose fan is running, right? Switch off your fan. It will not be stopped instantaneously. It will take some time unless the total momentum is getting lost from the fan. So whenever some motion is stored in a body, and that whenever external force you are not applying, you are running in a race, 100 meter you are going to stop. You want to stop, but you are not actually stopping over there, because during the motion, some motion has stored inside your body. That amount of motion stored, that is called momentum. That might come to you from some other body when it is colliding with you, or it might come to you because of your own motion. So motion stored in a body is called momentum. Momentum is represented as mass into velocity, and it is a vector quantity. Means magnitude and direction both it has. It's a vector quantity. Okay, momentum is important. So how to write momentum? Suppose I'm saying if this is a body and this body is moving with momentum v1, and that body m2 is moving with a velocity v2, not momentum, velocity v1, that is velocity v2, and these two body m1 and m2 I am taking for you as a system. So if I am asking here, what is momentum of the system? Momentum of system. So as I told you, it is a vector quantity. What you will write as an answer? Your answer will be m1 v1, m1 v1, and that is moving towards positive direction. And second I will write m2 v2 minus, because that is a negative direction, that is a positive direction. So total momentum of system is m1 v1 minus m2 v2. There are many applications on momentum, and then obviously the Newton's second law regarding the momentum, that we will discuss in Newton's second law elaboratedly, like momentum also. I hope Newton's first law all of you got. Okay, we will discuss some new topic also. I will come with the next lecture. So till then, enjoy your, revise well, and at last do fill the subscription form that is in the description. The form is there now. Sorry, that description form. Be the part of START program. I'm waiting for all of you. God bless. Bye bye.
Hello, Bacha. So up to now we have done molarity, right? Yesterday we finished almost our topic molarity, right? So now our next topic is molality. First of all, from yesterday topic, I will ask you one simple question. Tell me, molarity. Molarity is what? N by V, number of moles of solute divided by volume of solution. Volume was coming, right? Tell me, molarity is temperature dependent or independent? We are doing this question from start, right? Tell me, molarity is temperature dependent or independent? Yes, everyone? Tell me, molarity is temperature dependent or independent? Dependent, right? Very good. Right. Why is this temperature dependent? Why? Because we are having volume in this formula, number of moles of solute divided by volume of solution. So volume is coming, volume is temperature dependent, and that's why the molarity is also temperature dependent, right? Very good. Okay, the next term, our next term bache is molality. This is molality. Clear? So carefully see, the next term is molality. Okay, bacha? In molality, see the difference, right? It is not RET, it is litre. Sometimes we do mistake. It is not molarity, it is molality. Clear? It's a different term. We can say it is defined as number of moles of solute per kg of solvent. Or I can say, first of all, how we show it? By small m. Small m is symbol for molality. And what is the formula beta for molality? It is number of moles of solute, right? And here what we have? Weight of solvent. Be careful, it is not weight of solution, it is weight of solvent. In which units beta? In kg. In kg. So moles of solute divided by weight of solvent in kg, right? Okay, bacha. Tell me now, this term, the molality, is temperature dependent or independent? Answer me very fast. By looking the formula, tell me, anywhere volume is coming? No. Tell me, this is temperature dependent or independent? Please make it fast. Very good. Yes, it is independent. It is temperature independent. Right? Its value will not change if you change the temperature. Very good. Great, bacha, great. Clear? So we can do one simple question, bacha, on this. So please answer this question. We are having here, I am saying, we are having 2 moles. We have here 2 moles of glucose, and here we have, I am saying, it's a 500 gram of water. Solute is glucose and solvent is water. So please tell me the molality. Please tell me the molality of the solution. What is the molality? Fast, fast. Very good. You're doing great. Yes. Giving the right answer, right? What is that? Moles of solute. How many moles? 2. Weight of solvent 500 gram. But don't forget to make it kg, because weight I said in which unit beta? Kg. To make it kg, I will divide 500 by 1000, right? So what is coming from here? 2. Very good. What is coming? 4. 4 mole per kg is the units, or you can say write small m. 4 is the right answer. Very good. Clear, bache, right? Next question, same way. This solution is having 90 gram glucose. This solution is having 90 gram beta glucose. I am saying here it is 1500 gram water. That is solvent. Right? So please find molality of solution. For your hint, I am telling the molar mass. The molar mass of glucose, for your hint, the molar mass of glucose is how much, bacha? It's 180 gram, right, per mole. 1 mole glucose have how much mass? 180 gram. Clear, bacha? Right, right. Yes, everyone. Molar mass 180. So first find the moles. First find the moles and then find the molality. Right, bache? Very good. Fast, fast. Very good. Yes. Again, you are giving right answer. If you look carefully, how many moles of glucose we are having actually here? How much? 90 is the given weight divided by molar weight. How many moles, beta? Half mole. We have half mole of glucose. Now, I want to find the molality. What is that? Mole of solute divided by weight of solvent in kg. Right? How many moles we are having? Half mole. 1 by 2 mole. 1500 gram water. Make it kg by dividing 1000. Right? So what is coming finally? 1 by 2 coming from here. If you solve, what is coming? 3 here and 2 here. Right? Very right answer. What is coming? 1 by 3. 1 by 3. Very good, bacha. Krishna. Right. Manisha, Janvi. Very good. 1 by 3. Molar solution. Fine. Great. Clear? Now one more question. Be careful. You have to take the weight of solvent, right, in kg. Clear? Right? Tell me now. Carefully give the answer this time. This is our solution, and here we have, I am saying we are having 3, or I am saying It is having 10 gram NaOH. It is having 10 gram NaOH, and here we have 100, or I'm saying, imagine, I'm saying we are having 110 gram solution. We are having 110 gram solution. So find the molality of solution, bacha. 110 gram is the weight of solution, not solvent. Be careful about it. So please, carefully give the answer. 10 gram solute and 110 gram solution, right? Yes, bache, fast. For NaOH, if I give a little hint, the molar mass of NaOH is how much? 40. Molar mass, bacha, of NaOH is 40 gram per mole. So that you can find the moles easily, right? Okay, 2.5, 25 by 11, 2.5. Most of you are giving 2.5 answer, right? Okay, let us check. Well, okay, bacha. So first of all, let us find moles of NaOH, which we need, right? How many moles which are given weight by molar weight? How many moles? 10 divided by 40. Very right. How much coming? 1 by 4. 1 by 4 moles of solute. Very good. Now, I want weight of solvent. Bacha, what is weight of solvent? It is weight of solution minus weight of solute. Right? So what is coming from here? It is coming 110 gram minus 10. So our solvent is only how much? 100 gram. Don't forget about it. Right? Now our target bache to find what? Molality. Now I am finding molality, right? So 1 by 4 mole of solute. How much solvent? 100 gram. Make it kg by using 1000, right? So what is coming from here? 10. It is coming 10 by 4. Very right. 2.5 molal. 2.5. Right. Very good. Clear, bache? Very right. Clear. Okay. Now, I am giving you a relation. I am giving the relation with the mole fraction of solute. So please be careful. Write a note and write a shortcut. Small m, I am saying, is molality. Small m beta is molality. And chi, we know that. What is it? It is mole fraction of solute. It is mole fraction of solute. And bacha, if you want to find a relation between these, so what is the relation, bacha? Molality is equals to mole fraction of solute divided by 1 minus mole fraction of solute, right? Into what here? 1000. If our, and here we take normally the molar mass of what bache here? Solvent. The molar mass of solvent, right? Normally we take aqueous solutions. Normally we take what? Aqueous solution, bacha. So what do you write here? I will write here x divided by 1 minus x into 1000 divided by what? 18. Right? Or simply I can write directly, bacha, what is the relationship? M is x divided by 1 minus x into how much? 55.5. So please write the shortcut. Direct relation of mole fraction. Direct relation of mole fraction and what? Molality of solution. Okay, bacha? So please, I will ask question. You will use direct formula. How we derive these things, we will see in our offline classes, right? When you come to campus after NEET exam. Okay. A lot of students are asking, sir, when offline class will start. So you will come, bache, after NEET exam, right? After NEET exam, just in 1 or 2 days, right? You will come to campus. Fine, bacha. 18 I am taking. 18 I am taking. Someone asking, sir, why 18? Because molar mass of water. If I take water, so what is the molar mass of water? 18. because we take our solution in water most of time. So in case of water, what we take mass? 18. If solvent is something else, then mass, molar mass can change. But here we will take how much? 18. Clear, bacha? So please write the answer to this question. Please give an answer for this question. Question is, find molality. Find molality of aqueous NaO solution. Find molality of aqueous NaO solution if mole fraction of NaOH in solution, bacha, is how much? 0.1. If mole fraction of NaOH is 0.1, then find the molality. Please find it fast. Hurry. Right? Use direct relationship, give the answer. You want to find what? Molality. You want to find molality, right? Very good. Right. You see, bache, what is the mole fraction? I am writing the formula once again. Mole fraction of solute divided by 1 minus x into 55.5. I can take 55.5 because it is aqueous solution, means water. So from here, it is coming how much, bacha? 0.1 divided by 1 minus 0.1 into how much? 55.5. What is coming from here? 0.1 divided by 0.9 into 55.5. If you cut it down, how much coming? 55.5 divided by 9. So please give the answer. Yes, everyone? Very good. How much coming? 6.16. 6.16. Very good. Very right. 9654. Right, bacha? Yes. 6.16. Very good. Clear. Very right. Very right. Okay, bache. Same one more question. Find. Okay, bacha. Find molality of aqueous glucose solution if mole fraction, carefully give the answer, bache, if mole fraction of water in solution is 0.8. Carefully give the answer. In this question, mole fraction of water is given, not mole fraction of glucose. In this question, mole fraction of water is given, not mole fraction of solute. So first find that. Careful. Yes, everyone? You see, bache, the mole fraction of solute plus mole fraction of solvent equals to what? 1. The mole fraction of solute, if you want to find, it's how much? 1 minus mole fraction of solvent. Because I told you, sum of the mole fraction of all the components equal to what? 1, right? So from here, bacha, 1 minus 0.8, how much coming? 0.2. That means mole fraction of glucose. Mole fraction of glucose is how much here? 0.2. Fine. Clear, bacha? Now apply the formula. Now apply the formula, you will get your answer very easily. Give me answer very fast. Give me the answer. Right. Yes, we want to find molality. 0.2 divided by 1 minus 0.2. As water is solvent, so I can take what directly? 55.5, right? So from here, 0.2, 0.8. 1 by 4. 55.5 divided by 4. What is coming? Very good. 13.88, 13.85. Very good. Right. Okay. So I'm saying 13.8. Clear, bacha? I hope you understood the relation of molality and mole fraction. Fine? Right. Very good. This bacha NEET exam is on 5th May, and after that you will come to campus for offline classes, right? Clear? Okay, and yes, don't forget to fill the form in description, right? And recommend your friends also, and we will start offline classes after NEET exam, right? Okay, bacha? Next one, please find the question and give the answer. 18 gram of glucose is dissolved in how much water? 500 gram. Calculate what, bacha? Molality, small m, right? Hint I am giving. Glucose means what? The molar mass of glucose, how much, bacha? Is 180 gram, right? How I am finding, bacha? Look at this carefully. Glucose means what? C6H12O6. It is the formula of glucose, right? Carbon have how much mass? Carbon beta have how much mass? Carbon have mass 12. How many carbon? 6. 12 into 6. Plus hydrogen how much mass? 1. How many hydrogen? 12. Plus oxygen mass beta how much? 16. How many oxygen? 6. If you sum up all of these, how much coming? 180. 180 is the molar mass. 180 gram is the molar mass of glucose, right? Very good. Now, come to our solution. We want to find moles of glucose, right? How? Given weight by molar weight. How much coming, bacha? 18 gram. 18 divided by 180. How much coming? 0.1 moles, right? Now I want to find molality. What is that? Moles of solute divided by weight of solvent in kg. That is 0.1 mole. How much solvent? 500 gram. Make it kg by dividing 1000. So how much coming? Yes, 0.2 molar. You are doing very well, and you are doing very fast also. It's a good thing. You're solving questions very fast. Yes. All subject corner. Beta, what is your real name? Huh? You are giving right answers. Good. Okay, bacha. Right? Next question I am going. Fine. Please calculate the, again they are asking what? Molality. What is it? 2.4 gram ethanoic acid in how much solvent? 75 gram. 2.5 gram ethanoic acid. Let me give you a hint first of all. Ethanoic acid means what? CH3COH. It is our ethanoic acid, right? I can write it as this also. C2. How many carbon? C2. H4O2, right? C2H4O2. Clear, bacha? Now, if you want to ask the molar mass, you can find by yourself also, right? The molar mass of ethanoic acid, how much, bacha? How much? You see? How many carbons? 2 carbons. 1 carbon, how much mass? 12. 2 carbons, 24. 1 hydrogen, 1. 4 hydrogen into 4. 1 oxygen, 16. How many oxygen? 2. What is coming from here? Right. What is coming? How much coming, bacha? 24. Plus 4, how much? 28. And 32. 60? Very right. Yes, this way I am finding the molar mass every time. 60 gram per mole. So this way you can find by yourself, right? To find the molar mass, you should have information about the atomic weights of element, right? So from here bacha, now the very easy, give me answer. Molality, how many number of moles? 2.5 gram divided by 60, the moles divided by how much solvent? 75 gram solvent, make it kg by using 1000, right? So what answer is coming bacha? Fast. Dikshita is saying 125 by 3, 0.5. Please check carefully, right? Okay, bache, so if I write it properly, how much coming? 2.5 divided by what here? 60. How much here? 75. And what here, bacha? 1000, right? Clear? If we cut down this, what is coming? 1 0 is gone from here, right? Now 25 into 3. 25 into what here? 4. 4, 2.5 giving how much? 10. Right? 10 divided by what is it? 18. 10 by 18, or you can say how much beta? 5 by 9. 5 by 9 molar. 5 by 9 molar, right? 5 by 9 molar. Clear bacha? 5 by 9. Very good. Yes, or you can say, if you want to solve this thing, what is coming? 0. How much? 9, 5. Right bacha? 955. That's it. 0.55. Very good. Yes, everyone? Good. Done. I hope you get the point. Next one. Find it. Fast. Again, I am giving a hint here first of all. The molar mass of NH. The molar mass, beta, of NH how much? Sodium 23. Oxygen 16. Hydrogen 1. The molar mass of NH how much? 40 gram per mole. Now see the question carefully and give me answer. Right? Yes, everyone. 10% weight by weight solution means what? It means 10 gram NH in how much gram solution? In 100 gram solution, right? This na? We have done weight by weight percentage. It means 10 gram NH in 100 gram solution. So from here we are very much clear that 100 gram solution, if it is containing 10 gram NaOH, means solute, how much is the weight of solvent? 90 gram water, or you can say solvent. Right? Clear, bacha? Now it's very easy. I want to find moles of NaOH first of all, right? How much coming? 10 by 40. Molar mass 40, so how much coming? 1 by 4. Okay, bacha? So from here we can see what is coming? Molality. Mole of solute 1 by 4. How much solvent? 90 gram. Please make it what? Kg. What is that coming from here? If you solve this thing, it's coming 1 by 4 will come and 9 will come, right? And if I cut down 1 0, so what is coming here? 100. That means further you can cut it down. 2 is coming, 50 is coming, right? Or 25 directly you can say, right? So 25 by 9. Tell me answer, what is coming, bache? 25 by 9, right? You can say 2.8 almost, right? Almost 2.8, almost. Right? Or you can say 2.79, 2.78, right? Almost 2.8, almost. Clear? I hope we are clear here. Clear, bache? Done? Okay, good. Next one. Fast. Next one is calculate the molality and mole fraction. बच्चे, you are saying find molality and mole fraction in what? 20% weight by weight Ki solution. Same type of question they are giving, but Ki is little complicated for you. So I am doing one thing. I am making this question easy for you. I am saying you can say NaOH. I am making easy for you, right? Okay, I am making easy for you. So please take 20% NaOH. Imagine, right? And then solve the question. I am saying 20% NaOH, then solve the question, right? Same question just we did just now. They can give any solute, it's fine for us. They can give any solute, it's fine for us. But just to make calculation easy, take here NaOH, right, bacha? What that means again? It means 20 gram NaOH in what? In 100 gram solution. Weight by weight percentage means 20% weight by weight means what? 20 gram NaOH in 100 gram solution. So what is coming from here? It means this solution have 20 gram NaOH plus what? 80 gram water. Right? If I want to find the what? Moles of NaOH, how much coming, bache? Moles of NaOH. 20 divided by how much? 40. 1 by 2 moles, right? 6.1, 6.1. Someone is saying yes, molarity is 6.1 something. 6.01. We will check. Great. So what is molality? Moles of solute divided by weight of solvent 80. To make it liter, I am taking about here 1000. So what is going, bacha? 1000 divided by 160. If you cancel out this thing, what is coming then? Yes, it's coming how much? 25 by how much, bacha? 4. Yes, very right. Coming how much? 6. Yes, 6 point how much? 25. 6.25. Right. Very good. Very right. All of you are doing great. And you are doing it very fast also. Some students are giving very fast answer. It's a very good thing. Because NEET is not just the knowledge test. Speed test also. In the NEET exam, you have to be accurate as well as your speed must be good. So NEET is completely a game of what? Time. Time management. So if you are fast, it's very good. Right? Good. Okay. Now the next part, what they are asking, bache? In next part, they are asking what? Mole fraction also. They are asking mole fraction, right? Can you find the mole fraction of NaOH? What is that? Moles of NaOH divided by total moles, right? Right, bache? Clear? So, if you check, bacha, how many moles of NaOH coming? 20 divided by 40 are the moles of NaOH. Total moles how many? 20 by 40 moles of NaOH plus moles of water. 80 by how much? 18. 80 by 18. Clear? Calculation you will do by yourself, right? I am saying once again, in this case 20 gram is the weight of NaOH, 80 gram is the weight of water. If you want to find the moles of NaOH, how much? 20 by 40. And moles of water, how much? 80 by 18, right? So moles of NaOH divided by total moles will give you mole fraction of NaOH. And by chance, if he is asking the mole fraction of water also, so what is the mole fraction of water? 1 minus mole fraction of NaOH, right? 1 minus mole fraction of NaOH. Fine, bacha? Right? Great. Okay, fine. Yes, 1 minus mole fraction of NaOH. Because if there are two components in solution, the mole fraction of both will be equals to 1. sum of mole fraction of both will be equals to 1, right? Very good. Please, next one. Yes, bacha, same question based on relationship of mole fraction and molality. So please do it fast. Do it fast. Right. Answer fast. Answer fast. Mole fraction they're asking this time. And what is given, bache? Given is molality is how much? 3, right? I know the molality is what? Mole fraction of solute 1 minus mole fraction of solute here into how much? 55.5, right? Clear, bache? So molality is given how much? 3. X divided by 1 minus x into 55.5, right? Multiply here 3 minus 3x equals to how much? 55.5x. Clear, bacha? Now, if you solve this thing, what is coming from here? 3x, I will take this side. So 3 equals to 58.5x. 3x will go here, will add up, right? So what is coming from here? What is x, bacha? X is 3 divided by 58.5. This is your mole fraction of solute. This is your mole fraction of solute. If solute is NaH, this is the mole fraction of NaH. What is coming? 0.55. 0.55 you are saying? 0.55 should not come. Because 30 will not make it, I think it will come around 0.055. If you check by yourself, I am just giving an idea, you can find by yourself. Divide you can do, right? Clear, bacha? So 0.05 something. You can check by yourself. Fine. 0.512. Maybe possible, right? So I am saying just approximation here. You can go further. Right? Okay, bache? Done? Very good. So now I am asking a question related to all the terms which we have done up to now. Clear, bache? So please look at this. Out of these, tell me which term is temperature dependent and which term is temperature independent. I am writing all the terms which we have done, right? The first term was what we did? Weight by weight percentage. Second term was what? Weight by volume percentage. Third term was volume by volume percentage, right? And fourth term we did mole fraction, right? Next we did what? Molarity, right? And sixth we did molality. Clear? Out of these, you have to tell me the number only. How many of these are temperature dependent? Please, just number 1, 2, 3 like this way. How many are temperature dependent? Very good. Right. Right, everyone. Fast. Yes. If we check carefully, weight by weight temperature, there is no volume thing. Temperature independent, right? This one, temperature dependent. Next one, beta, volume by volume, definitely temperature dependent. Right, good. Mole fraction, again, temperature independent. Right? Molarity, temperature dependent. Because volume comes in this formula. And last bache, molality, temperature independent. Right? So if we count the terms, how many which are up to here? 1, 2 and 3. 3 are dependent, 3 are independent, right? There are 2, 3 which are more terms. There are 2, 3 more terms which we'll do in our offline classes, right? Like there is one term, strength, and there is normality, right? And ppm, some terms are there, okay? So you can do. Okay, I will take 1 more minute and I will tell you about the strength, because it is very simple. It will take very less time, so you can understand strength also, right? It's very simple. What is strength, bache? If you see this term, I am saying 7th term, strength of solution, right? So bache, what is strength of solution? See carefully. Just one question I will give here. It is weight of solute in grams. Weight of solute in grams, right? And divided by volume of solution. Divided by volume of solution in liters. It will not come in so much use, but yes, you should know about it also. It is weight of solute in grams divided by volume of solution in liters, right? So please answer just one question from here. This is our solution. It contains 40 gram glucose, right? And I am saying here we are having 800 ml solution. In 800 ml solution, bache, we have 40 gram glucose. So please answer this. 40 gram glucose in 800 ml solution. Weight of solute divided by volume of solution. Very good. Very right. Tell me the answer. Strength I am saying, right? You see 40 gram solute divided by 800 ml. Make it what, bacha? Make it liter. How much coming? 50. Okay, very good, right? What is coming from here? If I cut it down, right? What is coming from here? 4 here, 20. Right? We cut it down. How much coming, bacha? 50. Yes. 50 gram per liter. 50 gram per liter. Very good. So we did 7 terms, right? And one thing more, tell me, it is temperature dependent or temperature independent? Tell me. Strength. Temperature dependent or independent? Temperature dependent or beta independent? Fast. Volume is coming here. Volume is coming. Very good. It is also temperature dependent. It is also temperature dependent. Right, bache. Very good. Clear? Done, bache? So this is it. We covered almost our 7 concentration terms, right? From tomorrow you will do some new topic, right? Clear, bacha? So I hope these classes are helping you. So don't forget to fill the form in description. Okay, bacha? Okay then, bye. See you all. Bye, bache. Bye.
Today in our botany session, what we are going to do, we are going to revise the previous topic, the tissues, whatever we have discussed, and completing the histology part regarding the plants today itself, right? We are pending with few of the things. We are going to revise the tissues topic. Those who joined late, they will get advantage, and few concept if you are not clear, because this is a slightly mixture of a lightly tough and easier stuff. Easier we have completed with the external morphology, and internal is a slightly thing where you have to focus more. So for that focus we need to revise more. So in our this session of histology, we have to revise the concept what we have discussed, right? Then for today our tissue are going to be complete, And which tissues we are discussing here? Plant tissue. Means we are discussing the histology for the plants. Getting that? So let me to start with our today's topic now. The tissues with the revisions first of all, and we will take more for the revisions so that you can get benefit of any doubt if you are, it should be clarified here, and even those who joined late, they should be clarified and what is going on, right? Okay, let's start now for the revision. We discussed our topic, the tissues, right? And we discussed in the very beginning that the tissues we are discussing for which kingdom? We discussed about for the plant kingdom. Even in zoology nowadays, the lecture what is going on, the same thing based on classification is taught to you people, and it is running the hierarchy of classification. I repeat here, which kingdom we are discussing about? The plants. Under plant, which division we are discussing? Angiosperm. So in the angiosperm, which are the flowering plants, there we are discussing the tissues. Are you getting that? Very nice. The plant kingdom we are discussing, or plantae we are discussing as a technical thing, right? So that was in a very first session of histology we discussed. Then even we discussed hierarchy of organization or biological organization. You should not confuse with the hierarchy of classification and hierarchy of organization. What is hierarchy of organization? Like by which the things will build up their full organism structure. Like it must have a cell at least to declare this is a living. Whether now it is unicellular or multicellular, it is a separate thing. As we are discussing the plants, flowering plants, so definitely it will be multicellular. Like one cell is creating the tissues. Tissues are forming organ. Up to organ level, that is the plant kingdom. But organ system, then animal, that is for the animals you will discuss in the zoology part. Is that clear? So do remember that we are discussing histology, the tissue part. After the cells, the tissue part. Why tissues we have selected to choose? Because this is regarding the internal morphology. External morphology we have discussed in our previous lectures, right? Now focus only on this internal morphology, where we have discussed the tissues are of the two types, meristematic and the permanent. But before that, I will be interested to tell you the tissues are what. Can I say this is the group of the cells which is having common origin? Means they are derived from, they are formed from the common origin or the cells. Like meristematic, I discussed, it is giving rise to the permanent cells, right? So how the further classification, that we will discuss, right? So group of cells, very nice, which is having the similar function and common origin. Usually they are having the similar function, but they are having the common origin as well, right? So I hope so the definition is clear. You must remember, tissue is a cluster of the cell. They are performing, they are united together to perform one single function, and they are having common origin. I hope so now definition is clear. Now the tissues, after the tissues, you must remember that we are having in plant two type of tissues. The previous lecture I have given in a separate slide. Now I have clubbed that just to take it out, the overall impact of the types now, right? Now see here, we are having these types of tissues in the plants. One is the meristematic, second is what? Permanent tissue. Now listen again, meristematic means the cells which keep on dividing. That you call it as meristematic cells in that tissues. Please don't look to the full flow chart. Just focus on the points. Open your notes if you have written that, right? So, and respond to me if I ask you the question. Right now, we are discussing the types now under the tissues, plant tissue, meristematic and permanent, right? Under meristematic, we discussed they have various types, but that all type have some criteria for classification. That is based on position, based on origin, based on function, right? But before getting into that much detail, let's see the basic difference between meristematic and permanent. Meristematic, I repeat, these are dividing. In permanent, they are properly, or you can say they are specialized cell. These are which type of cells? Specialized, means these tissues are made up of specialized cell, means they have some particular function to perform. Are you getting that? They are no more dividing, right? Usually they are not dividing, right? And that group of cells you call it as permanent cells, right? So two headings are clear, meristematic and permanent. Meristematic means keep on dividing, permanent means now they are permanently assigned some work, they are no more dividing. That cells you call it as which cell? Permanent cells, or the constituting that tissue. Right, now coming back on the meristematic one, let's check on this. This is like a map in front of you, that in our full session we had discussed this thing, and today we are going to revise that. We already discussed this part, this one and this one, means all meristematic types we have discussed. Simple, we already discussed parenchyma, collenchyma. Today we are going to complete with the sclerenchyma and this complex permanent tissue, that is pending part, right? So just to complete that much of thing, I will take in the last, but you should know the basic once again so that you feel comfortable with our today's topic, right? So I repeat, meristematic, first of all, based on the position. If I separate the meristematic from the permanent, like this, a bigger view if you want to write and to focus, that is now only meristematic, I make a separate slide for it. So meristematic, again I repeat, dividing cell. Now based on position, three are there: apical, intercalary, lateral type, right? Now based on origin, which three types are there? Promeristematic, primary meristematic, secondary meristematic. Based on function, we are having primary meristem and the secondary meristem. Is that clear? There is a slight difference between the word meristem and meristematic. Meristem is a point where it is present, or region, the place where the dividing cells are present, right? That place you called, or that region, that small space where, or the region where they are dividing, that region you call it as meristematic. Are you getting? Because full plant is not meristematic. Their position is at specific point, right? So that position you call it as meristem, and meristem inside is having which cells over there? Meristematic cells. Meristematic is like an adjective for the cell. Which type of cell? Meristematic cell will be there, right? So meristem is a region, whereas the meristematic cells are the part of that region. Clear? Okay. Now you must go with this first of all based on position. If I take for the position, we have discussed this diagram, right? Apical meristem is present at the apex. Apex of what thing? It will be present at the apex of shoot and even of the root. They are present at the shoot apical meristem. They are even present at the root apical meristem. In the shoot, it is giving the height. In the root, it is giving to the depth, right? Means the linear growth. They are helping in that. Whereas intercalary, even it is helping in the linear growth. But what is its location? It is present at the base of the internode, right? And earlier even I discussed with you, this is a feature especially in case of grasses which are monocot, right? And here it can be in both dicot and monocot, fine, right? So intercalary, you remember I said you, if this is a stem here, so it is having, like these are the node part, and what is this thing? Internode part, right? Usually the position of intercalary meristem is where? It is here. This is internode at the base of that. Usually we are having this intercalary meristem, and if the tip is there, it is having shoot apical meristem. So type of meristem, that is based on the position. This diagram will help you there, right? So I repeat, apex means at the tip. So what is the position of apical meristem? It will be at the tip of the shoot or of the root. Intercalary, where is there? It is at the base of the internode. Node and internode in morphology we have learned, right? That is a feature of the stem, not of the root, right? And here even you must know it is in the case of grasses, right? Okay, then is what thing? The lateral meristem. Lateral meristem, it is present lateral in its position. It is present lateral in its position. We discussed the apical, intercalary and lateral, right? I hope so. This is all fine to everyone. We discussed up to here, right? Now again, I am going to discuss with you about based on the origin. Fine? Okay, now I am taking this point based on the origin. This is important, right? Everyone must focus here. This is very important. There we have discussed three types according to a region: pro-meristem, primary meristem, secondary meristem. If you cannot retain full, not an issue, right? Just wait for the moment when you will be perfect for this. But understanding of the thing is separate instead of that learning the more. Both are different things. Learning more will come when you will revise it. Now you must understand the thing. Learning of all the thing in one go is not possible at all, right? Don't take much tension on this. Let me to take the 3 points again: pro-meristem, primary meristem, secondary meristem. What is the origin? Pro-meristem, earlier even I said you that it is from the basic part, that is from the embryo. It is related to the embryo. Embryo, you know that, which is formed after the fusion of gamete. Zygote will be there. It will undergo division to give embryo stage. We already discussed in the morphology that seed is containing the embryo with the cotyledons and embryonal axis. Now that embryonal axis has to give out the various type of the stages here, right? Embryonal stage, very nice. Embryonal stage we have discussed, that embryonal stage only on the pro-meristem. Fine. Second is what thing? Primary meristem. What is primary meristem? For at least don't forget that it is in the early stages of the life of the plant. It is from the beginning, because plant need growth throughout its life, and from the beginning till what is the life cycle, they keep on dividing. That's why their growth is unlimited as compared to animals. Animals, the growth will stop at certain stage because they don't have meristem over there, right? So do remember, in the early stage, embryonal stage, that cell you call it as pro-meristem, right? Then primary meristem is present in the early stage, or from the beginning it is present. In the early stage, from there it is present, that you call it as primary meristem. But that primary meristem actually undergoes specialization. It will, some of that, not all, some of that will stop dividing and it will be getting the primary permanent. Now they are stop dividing and giving some specialized function to perform. Like in roots we have discussed now, at the tip we are having the region of meristem. Then few of the cell will convert into for elongation. That elongation now turn up into the, which is having root hairs in the region of maturation, where the main function is absorption, right? So once the thing is becoming specialized for one specific function after stopping the division, that you call it as differentiation, right? Means they become specialized for some function. Their structure change, their speciality is going to be changed for this, right? Okay, now after primary meristem, what will come? Primary permanent. These stages are common both in monocots and dicots, right? But once the primary permanent start giving another category of meristem, which is secondary meristem, that happens in dicots only, because they have to expand in the width as well, right? Whereas monocots will not expand in the width. Dicot is going to expand in the width, not the monocots. That's why second half of this flow chart is only happening in case of the dicots, right? So this is happening in dicots. Exceptions are there. We are not after the exceptions right now. So you must know what is the origin of the secondary meristem, that is from primary permanent. Otherwise all cells ultimately are deriving from here. But after some changes, we are getting this secondary meristem, and that you call it as de-differentiation. D here means without speciality. Now this stop becomes special, again it start dividing. that you call it as what? De-differentiation. Now, why they have become meristematic? To add other set of the secondary permanent. Again, they are becoming specialized. That's why you call it as re-differentiation. Again, they are becoming specialized again to increase the width of the plant. Right? So, this is based on the origin. Right? Now, coming your turn now, you have to give me the answers for the questions what just now I discussed with you. Right? Okay. Now, say me one thing. The apical meristem is present from the beginning or will come later. Means you have to say me whether the apical meristem is primary or secondary meristem. Apical meristem, either of roots or shoot, no matter. Whether it is a primary or secondary. Beginning, very nice. From the beginning, what you call them as primary meristem. Very nice, very nice. Okay, now if I am saying that we are having like leaves, which is having mesophyll cell for photosynthesis, right? It is formed from some meristematic tissue, primary meristematic tissue. Okay, let me to say these are the primary permanent cell. Now, can you say me the process which is converting the primary meristem into the primary permanent? The process name, what do you call it as? Process name, differentiation. Very nice. Differentiation, very nice. I'm not asking the cell's name, I'm talking about the process. The word is differentiation, the word is not difference. Are you getting? No doubt it will create a difference, but the process we call it as differentiation. Are you getting that? Okay, now in the case of which type of plant? Monocots or dicots? Where we are having lateral meristem. In which case we are having lateral meristem. Monocots, sorry to say, wrong answer. Obviously, second we are left with dicots, right? Because dicots has to become expand, right? Come back on this point again. If you are giving the answer wrong means just focus back again. Very nice. Rest are all giving the dicot. Obviously, one monocot rejected. Then answer will be dicots, right? Okay. So let me do say here, when the secondary growth has to happen, which meristem is there? That is secondary meristem. In which case? In dicots. Are you getting that? So secondary meristem you will find in dicots. You will not find secondary meristem in monocots. Right? Primary meristem can be both in monocots and dicots. Even pro-meristem will be there in both monocots and dicots. See the way we are learning, see the way I am asking you the question. These are the level of the NEET, what you are learning, how to reversely you have to correlate, right? So just keep in your mind that based on origin, you are having pro-meristem, primary meristem, secondary meristem. Otherwise, origin of all will be pro-meristem, or if in options in your questions they have given primary meristem, then that will be your answer. Intercalary will even come under primary meristem, because to increase the length of the internode, that is there already in the beginning in a plant. Are you getting that? So which are there in the beginning and helping in the growth of the plant, that you call it as a primary meristem. Secondary meristem will show the lateral growth, and here the word I use the cambium, which is formed later in the life. Are you getting that? But here some exceptions are there which we need not to worry. But do remember here, at least even later I have discussed with you this point, like okay, let me to take for the function, then I will come on the origin point as well. I will come on that. But we are going to take one more thing. One more question, that's fine, but say me whether my voice is audible or not. Please put your thumbs up for this. Thumbs up, please. Yes. Just please give me the response. Okay, fine. So let's start with one more question. Okay, you need one more question on this. Let's check, because today is a revision of this topic, because I am feeling this is not commonly around you. You have to listen and you have to believe, right? So this is the only solution with us. Fine. So, okay, this is the thing what we have discussed. Clear? Okay, now let me to ask you the next question. what you call that process is when secondary meristem is converted into the secondary permanent. Secondary meristem into secondary permanent. What do you call that process as? Redifferentiation. Very nice. Naveshri, very nice, given the response first. Redifferentiation. It is not dedifferentiation, right? What is dedifferentiation? Primary enter into secondary. When primary into secondary entering, permanent into meristem, that is dedifferentiation. Just keep in your mind, when meristem is coming, it should be without speciality. When permanency is coming, it should be with speciality. D means without, re means again coming. Are you getting that? So just go with the things, how to split that. This is going to be very important and helpful to you in the rest of the things which we are going to discuss, right? So this is redifferentiation, not the dedifferentiation. Fine. Okay, so this is about the based on origin. Now based on the, we have to take function, right? 3 criteria we have discussed. What is that now? Last one for meristematic, that is based on the function. Primary meristem and the secondary meristem. Function now, what they are doing in the plant, right? If they are going to increase the linear growth, height we use the word for the stem and depth we use the word for the roots, because this is the main axis, the ground level where you have sown the seed. From there, who is going more in the height, who is going more away from the ground in the aerial part, that will be the stem part. So the shoot apical meristem will go away from this axis and root will go more in the depth. This is having root apical meristem, this is having shoot apical meristem, but both are helping in the linear growth of the plant. That's why you call it as a primary in function, because they are helping in linear growth. And which category will come here? Apical and intercalary, because intercalary will help in increase of the internode, whereas apical help in the overall increase in the linear lengths of the stem as well as of the root, right? Now who will be secondary in function, which help in the width growth of the plant, which happens in the late in the life of the plant, and it is in the older part. Base is an older part. When you go above in the plant, it will become the younger part. Younger part will not have the lateral meristem. Monocots will not have the lateral meristem, right? Then which type is having the lateral meristem? Dicots will have. In dicot, which part it is having? Older part. Like, let me to go back on that slide. Like here. Can you see? Same stem, upper part is younger and lower part is older. So younger part will not have lateral. Who is having lateral? Older part. Dicot, but in dicot, which part? Older part is having the lateral meristem. Is that clear? Cambium examples are so many, right? You will learn about further more terms. That's why I'm not using here. If you want, then it will be like interfascicular cambium. You are having intrafascicular cambium, vascular cambium, core cambium, right? So I don't want to be in the that much of the things in a one go. Just eat bite by bite. It will be helping in the proper digestion, right? So that's why we have to go only with the basic things actually. So here in the botany in the beginning, we have put a tinge of easy concept of the morphology. Now a little bit tinge of the things which you cannot see from outside. Are you getting that? Only internally you can see that, right? So both things you have to handle. Sometimes easy will be there, sometimes tough. So you should be balanced with all the things, right? Okay. So right now, don't worry about the words what I spoke, intrafascicular, interfascicular and core cambium. Don't worry at all right now. Only the terminology, only the main things you have to go, right? What is mean by the monocot and dicot? Please check the video we have put on the morphology, right? That's why I'm saying you from the beginning, fill the form given in the description, right? So that you should not miss all that. Otherwise, still let me to say, monocot is that plants which are having one cotyledon in the seed, like in a rice. When you soak it, when you press it, there is no splitting that. It will remain one. That is monocot. But in the grams, like white gram or black gram, when you're soaking overnight, just press it, it will split into two, means they are dicots, right? Monocot is help in height. Yes, it is help in height by the apical meristem, right? It will be held by the apical meristem. Fine. So, okay, back to the topic, because we have to wind up with the all the thing, and last we have to go with our the small topic we are left with, complex permanent tissue, that we have to take it, and the sclerenchymatous as well, right? Okay, this all we have discussed about the meristem, right? So, we have discussed based on origin, we have even discussed based on the function, that all we have discussed, right? Now coming to the next point, we have to discuss the permanent types. Permanent types, simple and the complex type. Simple, we have discussed that they are only having same type of cell throughout its section. Here you have variety of the things, like earlier even I mentioned you, right? In the complex type, it is heterogeneous type. Whereas in case of simple type, it is of the same type, like parenchyma, collenchyma, sclerenchyma will be there, right? Now, parenchyma, what are the features? Like the pictures even I have said you, this is parenchyma. What is the feature? Main, you must remember, it is having intercellular space. And do remember, very important, these are living cells. They consist of living cells. Intercellular space is small or it can be absent. Now, if I am discussing this one, this is for the parenchyma, which is thin wall, and this is for what thing? Collenchyma. In your NCERT book, they have shown this one, right? So, this one, can you see at the corners, thickenings are there? These corner thickenings, this is important, very important thing, right? This is very important, and even they are living. One student asked me, why you call it as living? If you are having the cytoplasm, right, protoplasm or cytoplasm, nucleoplasm, that all word we will clarify. But if that stuff plasma word is there, that means they are living. If that plasma is no more, that means they are dead. So out of that, these are living, right? Thick wall, thin wall, yeah, this one is thin wall, right? And this one is thick wall, but at the corners only corners. And these are for the sclerenchyma. Sclerenchyma is having throughout the wall, it is going to be thick, right? Now this is not longitudinal and transfer view. No, it is the, no doubt, the longitudinal view of fibers, separate thing. I must say this is longitudinal section, but of fibers. And sclerate is the another type. It is showing the transfer section here. Actually, sclerenchyma further of two types we will discuss. It is of fiber and even it is of sclerates, right? Two types are there. Earlier in that video, I have given you on longitudinal transfer. Even there we discussed longitudinal transfer for the same cell, but not same now. Under the sclerenchyma, two subtypes are there, fibers and the sclerites, right? No doubt for the fiber, this is longitudinal section. For the sclerite, they have given you the transfer section of it, right? Okay. Now, we already discussed in parenchyma. What we have discussed? You remember this mnemonic I have given you? Parenchyma means it is having thin cellulosic cell wall. Means I have given this term as mnemonic. What is mnemonic? Just giving some tricky thing or humorous thing just to learn the concept, because in botany you have more terminology. Maybe understanding is not required for name somewhere, understanding somewhat for breaking and learning the meaning of prefix, suffix, but somehow you have to manage this way or any way, right? But we have to learn at last. So parenchyma, this mnemonic I have given, S stand for their various shapes, all the shapes will come. But do remember that most of the cases, it is isodiametric. Isodiametric means it is having equal diameter in all the direction, means roughly it will be spherical in shape. Mostly that will be the shape. Otherwise, these other even can be found, right? L stand for they are living, just now I said you. I stands for intercellular spaces are there, which are small or maybe it can be absent. Absent means they are tightly packed. M stands for major component within organs. If you cut the transverse section of the organ, you will find majorly inside are the parenchyma. Then is what? Cellulosic cell wall. That thin cell wall is made up of cellulosic cell wall. And what is its function? It can help in photosynthesis, it can help in storage, it can help in the secretion. All three things not in one point, at different point. If I am saying in leaves, what parenchyma is doing? That is doing the photosynthesis. Are you getting that? And for the storage, like if I am taking in roots, like you have the storage type of roots we discussed in morphology, what they are doing now there, that is helping in the storage there, right? And secretion, like the resin, gums, latex, when you cut the plant, some things are coming out like gums you are extracting from that. That is all stored or secreted by the parenchyma, right? So these are the functions of the parenchyma and these are the features. This mnemonic maybe help you little bit, or other way you can learn, no issues for that. So do remember that these are for parenchyma. Next is for the collenchyma. Collenchyma, I said you, they are having thickenings at the corners. This is the important thing. Corner thickenings but made up of cellulose, hemicellulose and pectin. O stands for when you cut the dicot plant, a dicot stem, when you cut it, upside will be epidermis, which is made up of parenchyma. Just below that, what is there? Collenchyma. And where you observed it, I repeat, you observed in the most of the dicots, under the epidermis, right? Like we have there as a skin in the plants. What is there? Plants, they are having epidermis, right? You have other types of tissues for the animals. You will learn all the types named specifically. But here we are simply saying here it is an epidermis, which is protecting as a parenchyma outside. Just below that in dicots, you will find the collenchyma, right? Most of that. L, they are even living. They are having corner thickening, is localized. But it can be continuous in some cases, or somewhere it is in a patches, discontinuous. Then it is not having intracellular space, means they are compactly packed. And C stands for most of the cases, they even have chloroplast, due to which it can show assimilation, means it will help in photosynthesis. Other example, means other function for this is mechanical support. What is mechanical support? Like a plant is standing, due to high winds, maybe it can bend and again it comes back, right? So can I say this is flexibility? Who is providing this flexibility? Collenchyma. In morphology or normally in life, you see the leaves are fluttering like this in the air. The petiole part, the stalk of the leaf, what they are having to give this flexibility? They are having this collenchyma, right? So our last thing today we have to discuss sclerenchyma. This is the third type of simple permanent tissue. In this type, do remember, they are very important. Do remember, they are the dead cells. Means this tissue is made up of dead cells. You will not find in the labeling here protoplasm given, vacuole given, inside material is nothing there. Like suppose a room is there, na? You are sitting in some room right now, that room, you are the living component over there. Or whosoever is sitting with you at this moment or whenever, the living things are there in this room. If we are going out, all living are going out, can I say now this room will remain as a dead now? In the same way here in a cell, when the living plasma is no more, only that wall is left now in plant, that you call it as what? The dead cell. No doubt they are originating from living, but slowly and slowly the living things are disappearing. They are getting dissociated, right? So, sorry, that's why you call it as which tissues? Dead tissues. They lack protoplasm. Right, material inside the cell which is living, you call it as protoplasm. They lack it, they don't have, that's why you call it as dead, right? And they are having thick walls, thick lignified, means extra thickenings are there due to what thing? Lignin. Lignin is such a material, when you keep on depositing on that, it makes the wall so much thick lignified cell wall is present over there. Are you getting? But they can communicate one cell with another. Other can even do that. But here they are having a special type of things to communicate with each other. Like this cell, if it is there, like this cell, if it is there with one more cell, of this, which you call it as fibers. Can you see it is having like a pointed end? Pointed end means like a needle it is having there, right? So this is communicating with the help of these pits, right? This thick wall cells, what they are having, pits to communicate with each other, like a window is there between two rooms, right? So they are like that, right? So this is about what thing? Sclerenchyma. Two types I already discussed. Under that further two types are there, fibers and the sclerids. Sclerids are much more thick. Fibers are okay, they are thick, but less than that the sclerids. Much more is there. Just right now you must know what is sclerenchyma. This is more important. What is the function now? What is its function? Can I say it will provide mechanical support? See, mechanical support is even provided by whom? Mechanical support is even provided by the, you can say collenchyma. But collenchyma are living. This is even for mechanical support, but they are dead cells. But it is providing rigidity. Rigidity means what thing? Like this, my finger, I can do like this. This is flexibility. But this marker, I cannot bend it like this. This is rigidity. Are you getting that? This flexibility in plants, who is giving? Collenchyma. But this rigidity in plants, who is giving? Sclerenchyma. Right? So both are mechanical support, but this is for rigidity, that one is for the flexibility, right? Now last thing of the day is what thing? Complex permanent tissue. I already just look at the picture. No need to go with the labeling. Just have a view. Complex permanent tissue, xylem and phloem. They help in conducting the thing from one place to another. Simply like you are having pipes in your home now, where the water is coming from the ground level to the reservoir. It is by the pipes. In the same way here, the plants are having so many such pipe. And this part is for what thing? Xylem. And this is for what thing? Phloem. Right? What xylem is conducting? That conducts water from water plus minerals from roots to aerial part. What are aerial parts? Aerial parts are like upper parts. Under the ground, they want to go upside like roots. Very nice. From the root it will start, but it will be carry on up to the upper part. Right? So that role is done by the xylem. Right? And who is performing the part for the conduction of the food now? That will be the phloem. So what phloem do? That conducts food. Which food? Which is formed by the leaves. Can I say from leaves to other non-green parts? Non-green parts means they cannot make their food. Usually from leaves to the roots. Right? So word usually is important. Why? This is not required right now. Only you have to use the word usually here. This is very important. Earlier even I said you, right? So do remember, usually from the this leaves part which is green, this will be the green part. To which part? Non-green parts of the plant. Which pipeline is helping in that? Phloem. And in the water case with the minerals, the xylem. Are you getting that? So that is the complex now. Why complex? Earlier even I said you through this slide. Have a look on that. This one. Right? Because they are made up of this part. Because xylem is made up of 4 different components. Phloem is made up of rest 4 different components. All the cells will not look same type. All will be having different types of their appearance but they are collaborating for common function. Like xylem is made for conduction of water and minerals. Phloem is for the food. What the leaves have prepared. Full body is not preparing food, right? So green part is preparing that. And giving to which part? Non-green part means which fails to show the photosynthesis, right? So this is the duty of this complex permanent tissue, right? So in this way, we have completed the tissues in a short terms, and where complexity comes, We have raised that level and be on the basic thing like the way we have discussed today, to revise the previous and then grow more of the new things here. We have much more to discuss on the tissues, right? But you must be clear with this basic line first of all, only then you can move on the complex thing, right? So this is all on the tissues. From the anatomy of the flowering plant, we have to touch only the tissues part for the basic thing, right? All the best. Have a nice day. Thanks a lot.
In the last class, I started the introduction towards the human physiology. Okay, and in the introduction towards the human physiology, I said first part, that is not in NCERT, that is the digestion and absorption. So how we are getting the food, how we are respiring, this all. And I said breathing and exchange of gases, it is including our respiratory system. Nose is there, pharynx is there, larynx is there, trachea, bronchi, lungs, all are there. Already I explained. Now give me the answer of one question. Give me the answer of one question. What is the structural and functional unit of the lungs? What is the structural and functional unit of lungs? Anyone will say, please reply, what is the structural and functional unit of lungs? Yes, Jyoti, very fast. It is the alveoli. Alveoli. Alveoli is the structural and functional unit of the lungs. Now, second question, please listen it. What is the partition between thoracic cavity and abdominal cavity? What is the name of the structure? Who is dividing the thoracic cavity and the abdominal cavity? Yes, very good. That is the phymi. That is the diaphragm. Diaphragm is the structure which is dividing the upper cavity with the lower cavity. Diaphragm. I am coming on the last point. What is diaphragm? It is a bone, it is a cartilage, or it's a muscle. What is your answer? What is diaphragm? Diaphragm is a bone, a cartilage, a muscle, and Jyoti has given the absolutely correct answer, and Venkata is also given the absolutely correct answer. It is a muscle. So diaphragm is a muscle, and this muscle is dividing upper cavity from the lower cavity. In upper cavity, all the structures are present. So this all I said during inspiration, during expiration. This is the one point that you have to remember. This diagram is saying about the double circulation and all. Now I am coming on the next one. How our body is getting the blood and what are the different types of blood cells which are present in our body. So first I will say, everyone knows what are the different types of blood cells present in our body. Anyone will say, what are the different types of blood cells present in our body? Written there. Divide into the three categories. What are the three major categories? Here only, yes, all the three. What are the three categories? Yes, very good, Bhavna. RBC, WBC and platelets. Yes, RBCs, WBCs, platelets. One is the RBC. These all are the WBCs. And this one is the platelets. This one is the platelet, that is the third one. So all the blood cells are divided into three: RBCs, WBCs and platelets. RBCs, WBCs and the platelets. Okay. Now in WBCs, if I will say, there are 5 types of WBC. How many types of WBCs are there? 5 types of WBCs are there. 5 types of WBCs are there. How to remember their name? So you have to remember the name with the help of a short form. Neelam EB. You can remember like this. Neelam EB. This is the short form to remember the name of the WBC. See, N for neutrophil. This is neutrophil N. N for neutrophil. L for lymphocyte. L for lymphocyte, they are the lymphocyte, the T lymphocyte and the B lymphocyte. M for monocytes, E for eosinophils and B for basophils. So how many types of WBCs are there? 5 types of WBCs are there. Very good, Surya Prakash. That is 5 types of WBCs are there. And this is the short form I have written to remember the name of the different WBCs. What I said? Neelam, EB, N for neutrophil, N for neutrophil, L for lymphocyte, M for monocytes, E for eosinophil and B for basophil. Okay. WBC is divided? No sir. Yes. WBCs are dividing cell. RBCs are not dividing cell because RBC is not having the division machinery. So this is the one point you have to remember, that there are 5 types of WBCs. Okay. That is neutrophils, lymphocytes, monocytes, eosinophils and basophils. Basically, all the WBCs are classified into 2 groups. One is known as the granulocyte and one is known as the agranulocyte. So if I will say that WBCs they are divided into 2 types. WBCs divided into 2. What is the first one? They are known as the granulocytes, and second one is known as the agranulocytes. There are 3 types of granulocytes and there are 2 types of agranulocyte. There are 3 types of granulocyte and there are 2 types of agranulocyte. You all are writing correct? Yes. Anyone will say, what are the 3 different types of granulocyte? Out of these 5, find out the granulocytes. Out of these 3, find out the granulocyte. They are having the granules. Find out the granulocyte. Say me, anyone will say, one is the acidophil. Acidophil, also known as the eosinophil. They are having the acidic granules. They are having the acidic granules. Acidic granules. That is why they are also known as the acidophils. Acidophils they are known as the eosinophils. Second are having the basic granules. They are known as the basophils. And third, it is having granules which are neither getting stain from acidic color nor getting stain from basic color. They are neutral. That is why they are known as the neutrophils. So what are the 3 types of granulocytes? 3. One is the acidophils or eosinophil. One is the basophil. And what is the third one? That is the neutrophil. Monocytes and lymphocytes, they are the agranulocytes. They are not having the granules, so they are the agranulocyte. Very important question, I think known by each and everyone. So be ready with your writing pad and all. Okay. Listen the question carefully. Out of these 5 WBCs, which is the most important WBC related with the immunity? Most important WBC related with the immunity. Who will reply it first? Most important WBC related with the immunity. Yes, Syamala. Syamala Kathi. The answer is the lymphocyte. Very good. The answer is the lymphocyte. Lymphocyte, the most important WBC related with our immunity, that is the lymphocyte. So here we will discuss, and now I am going just, it is the introductory part, so I am saying something is in less words. So if I will say, we are having the different types of blood group, A blood group, B blood group, AB blood group and O blood group. How many types of blood groups are there? A, B, AB and O. A, B, AB and O. So if I am writing the A plus, A positive and writing the A negative, anyone will say, what is the meaning of positive and negative here? First say me, what you are getting from A positive blood group. What you are getting from A positive, because if I will ask what you are getting from B positive, so you will say always B positive. So what is the meaning? Yes, what's the name? Venkata Shiva Kumari Kola. Okay, here the positive and negative, it is representing another blood group, that is the RH group. RH group, there is another antibody which is discovered in rhesus monkey. Another antigen which is discovered in rhesus monkey, you know, rhesus monkey. That is why the name is given as the RH. So when I am writing A positive, it means the human being of this blood group, it is having the A antigen and it is having RH positive antigen, rhesus antigen positive. It is the A negative. Okay, it is the A negative. A negative means RH antigen is absent. Similarly, B positive, B negative, AB positive, AB negative, and O positive and O negative. So when you will come to our campus, I will say this all. Yes, the RH factor is an inherited protein that can be found on the surface of the red blood cell. Both RH antigen and A and B antigen, they are present only on the surface of RBCs. Clear? So this is the one. Now I am coming on one question. Who will reply? Who will reply? Be ready. Who will reply here? Just say me, what is the universal blood group and what is the recipient blood group? What is the universal blood group and what is the recipient, universal recipient? Nikhil is saying O. O means what? What, Nikhil? What you want to say? Nikhil, O means O positive or O negative? Which is universal? O positive or O negative? Which is universal? Someone has written, I forget to read because it is going very fast. Yes, the O negative blood group is considered as the universal donor and AB positive is considered as the universal recipient. See what I said, O negative, it is considered as the universal donor. It is the universal donor and AB positive is considered as the universal recipient. So now I am going to teach you something today which is different. Please be ready with pen and pencil. How to know? Just make one triangle. I have written A, B, and on the top of triangle I have written the OAB. If you will learn it today, throughout the life, it will come in your favor. And this is the O. Okay, so just see, this is one triangle O. O can donate the blood to all, but it is able to receive the blood only from O. That is why the O blood group considered as the universal donor. A is able to give the blood to AB. A is able to blood the blood to A, but only to take blood from A and O. Clear? B, it can give the blood to AB. O, it is also giving blood to AB. AB can also donate the blood to AB. That is why AB is the universal acceptor. AB is the universal acceptor and O is the universal donor. Just for 1 minute, see one block is coming on your slide. Okay, want to be the part of Star C Chaitanya Target NEET program? Please fill the form immediately. It is compulsory. Okay, without leaving, please fill the form very fast. Say me, how many of you already filled the form? Please give a thumbs up. How many of you filled the form? How many of you filled the admission form? Please give your thumbs up if you will did it. Okay, just. Okay, very good. Please fill the form. O can donate blood to all, but it is capable to take blood only from O. Okay, because blood groups are determined on the basis of antigen, not on the basis of antibody. So just whenever free now, please fill it very fast because it is compulsory. Okay, so now I am coming on the another part of the circulatory system. The name of our topic, that is the body fluid and circulation. And in body fluid and circulation, this is the structure of heart. How many chamber? Okay, I wrote first, but I don't see. Oh, very good, Neela Beni. Okay, don't worry. So it is running very fast now. You know, up till my eyes are moving there, it is running. So just no need to worry. When you will come to campus, I will recognize. Say me. I'm that I'm replying. Okay, now say me. Human heart. It is having how many chambers? 4 chambers. Just imagine which is the largest chamber in human heart. Out of these 4 chambers, which is the largest chamber of the human heart? Right atrium, right ventricle, left atrium, left ventricle. Which is the largest chamber in human heart? Yes, already written. Neela Beni, you have written answer. What is the answer? Others are also writing correct. Okay, left ventricle is the largest chamber. Left ventricle is the largest chamber. Left ventricle is the largest. Okay, science, Surya. It is not ventricle, I asked largest chamber. Largest means there are 2 ventricles now. One is the right ventricle, one is the left ventricle. See, right ventricle sending blood only up to the lungs, and left ventricle is sending blood to the different parts of the body. So where more power is required? More power is required in the left ventricle. Okay, more power is required in the left ventricle. So that is why, what is the largest chamber of the heart? That is the left ventricle. Left ventricle is the largest chamber of the heart because left ventricle is supplying blood to the different parts of the body. That right ventricle, it is not the largest chamber because right ventricle, it is supplying blood only up to the lung. So this is the one point. Have you seen the ECG? Say me, have you seen the ECG in reality? Have you seen? What is the use of ECG? Because when we will come to our campus, we will discuss it in detail. Just say me, I want to know the basic knowledge, what you are getting, what we are getting. Yes, it is the electrocardiogram. Very good. You people are very intelligent. Yes, electrocardiogram. Yes. Jaya has written that ECG is used to count the heartbeat. Very good. Anyone will say, anyone else? Heartbeat rate. Yes. Hasini, you are saying heartbeat rate. Indicate pulse. Pulse means that is the same as the heartbeat rate, like I said. Okay. ECG is also indicating about the health of the heart. You can say ECG is indicating about the health of the heart, and with the help of ECG, we are able to identify the heart attack. Heart attack. With the help of ECG, we are able to identify the heart attack. There are different waves, P, Q, R, S, T, and these waves are indicating the different events. Clear? These waves are indicating the different events. So when you will come, I will say in detail, that is about the ECG. See how the blood is flowing. So there are 2 circuits. There are 2 circuits related with the circulation of blood. Related with the circulation of blood, there are 2 circuits. One starts from right ventricle, ends into the left atrium. One starts with the left ventricle, ends into the right atrium. So just see, this is the impure blood. This one is the pure blood. This is the pure blood. This one is the impure blood. So heart blood circulation, it goes in this way. if I will say the flow of pure blood starts from left ventricle and impure blood is coming into the right atria. This is one circulation. Second one, that is the impure blood going from the right ventricle to the lungs and coming back to the left atrium. So this is the one point. Yes, Harshita, I will read. An ECG is a test that records the electrical activity of your heart. Not only my heart, everyone's heart, including the rate and rhythm. Very good. Okay, so this is the one definition, that to record the cardiac activities. Proper functioning, proper contraction of the heart, proper relaxation of the heart, and someone has written the very correct, it is used to identify the heart attack, that is myocardial infarction. Yes, science teacher, you said it is the double circulation. Now, double circulation, I will come on this point, why this circulation is known as the double circulation. Why this circulation is known as the double circulation? Why the blood circulation which occurs in the human beings is known as the blood circulation? Yes, Venkata, Nikhil. Okay, yes. All are giving the correct answer, because during circulation, the blood passes twice through the heart. First, impure blood, second, pure blood. That is why this circulation is known as the double circulation. One is the pulmonary circulation. One is the pulmonary circulation. Another one, that is known as the systemic circulation. One is the pulmonary circulation, another one is known as the systemic circulation. So from heart to the lungs, that is the impure blood, and from lungs back into the heart, that is the pure blood. It is known as the pulmonary, because pulmonary term is used for the heart. From heart to body parts, and from body parts again back to the heart, this is the pure, this is impure. This is known as the systemic circulation. Clear? So there are two types of circulation: pulmonary circulation and systemic circulation. Now just be ready, because I am going to share one question. Are you ready? Are you ready to write the answer of this question? Say me, listen carefully, one question. Okay, say me. Normally arteries are carrying the pure blood. Normally arteries are carrying the pure blood. Name of the artery which is carrying the impure blood. What is the name of the artery which is carrying the impure blood? And Fahimil Sheikh has given the Nikhil, Fahimil Sheikh given the fastest answer, that is the pulmonary artery. So in my view, you all are good. So whenever you will come to our campus, just meet me, because I will be the happiest person. So many I am knowing by your name. If your name are correct, then definitely I will recognize. Okay, that's why I used to say, write your correct name. How I will recognize when you will come to campus now, that you will replying very fast or not replying? When you will write your correct name. Otherwise, if you will write a different name, how I will recognize? So this is the one. Okay, so this is the one that pulmonary artery is having the pulmonary term is used for the lungs. Pulmonary, that is for the lungs, pulmonary, not for the heart. For the heart, we are using one term. That is the cardia. For heart, we are using one term, that is the cardia. So this is the one point that you have to remember. Related with the heart, there is one disease that is known as the hypertension. So please give me the answer of one question, because points are known by you. What is the name of the apparatus which is used to measure the blood pressure? What is the name of the apparatus which is used to measure the blood pressure. Say me, no problem. What is the name of the apparatus which is used to measure the blood pressure? Yes, 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 yes. All are giving very much correct answer. Sphygmomanometer. Sphygmomanometer is the name of the apparatus which is used to measure the blood pressure. Clear? This is the sphygmomanometer. Now, first I will remove the slide. Then I will ask, what is the normal blood pressure of a healthy human being? What is the normal blood pressure to the healthy human being? Yes, Dikshita, you have written absolutely correct. That is the 120/80. Okay, 120/80. That is the not 80/120, 120/80. Because first we are writing the systolic, then we are writing the diastolic. So this is the one, that is the blood pressure 120/80. Now there are so many diseases like angina, heart failure, heart attack and all. In the human physiology, till time I said, digestion done by the digestive system, respiration takes place with the help of respiratory system, circulation of blood with the help of circulatory system. Now, if there is formation of urea, yes, in hurry maybe I said, so just you may correct it, no problem, because I think you are getting cardia term is used for the heart. In very first class I said cardia, pulmonary term is used for the lungs. Okay, so now just coming on the next one, that is the excretory. So human beings, what is the excretory product in human beings? Anyone will say, in human beings the excretory product is the urea. Urea is the excretory product, and that is why excretory product is the urea, so we are known as the ureotelic. We are the ureotelic because what is the excretory product? That is the urea. So that is the ureotelic. Okay, so this is the one point. Now, important excretory products are ammonia, urea, uric acid. They all are the nitrogenous base. And just see, what are the different structures related with the human excretory system? So just see carefully. That is a pair of kidney, a pair of ureter, one single urinary bladder and one urethra. If I will draw the diagram like this, this is one. A pair of kidneys are there. Okay, from kidneys what arises? Ureter. Ureter arises from kidney. So this is the one point. Then it is having the urethra and it is having that is the urinary bladder. This one is the urethra. A pair of, that is the ureter. And what is this? This is a pair of kidneys. Anyone will say, yes, that bean-shaped kidneys are there. So this is the one point. A pair of kidneys, a pair of ureter, one single urinary bladder and one urethra. These are the different parts of the human excretory system. Now Krishna said nephron. So each kidney of human being, it is made up of approximately 1 million units. These units are known as the nephron. So kidney is made up of units and these units are known as the nephron. What they are? They are the nephron. Nephron also known as the uriniferous tubule. Nephron also known as the uriniferous tubule. Yes, Hasni, you are absolutely correct. They are the functional unit of kidney. One more person written earlier, but I am unable to read. Okay, nephrons, they are the uriniferous tubule. They are the functional unit of kidney. Okay, functional unit of kidney, that is the nephron, and approximately 10 lakhs nephrons are present in one kidney. So nephron is the uriniferous tubule which is related with the filtration of blood. Loop of Henle, Tanmay, loop of Henle is a part of nephron. This just see. There are two limbs of the loop of Henle. One is coming down, descending, and one is going down, ascending. Dikshita, you said PCT, DCT. It is the nearer, it is the distal. So it is the proximal, nearer, and away, that is the distal. Clear? So this is the one that you have to remember. Proximal tubules are there and distal tubules are there. So what is the function of nephron? Anyone will say, what is the function of nephron? Anyone will say, what is the function of nephron? What is the function of nephron? Anyone will say, what is the function of nephron? Yes. What is the function of nephron? To form the urine, beta, to not filter. Ram, you are writing correct, but urine formation, filtration of blood, that is the function of nephron. In human beings, I am asking a general question. Relax. First relax. Take a deep breath and then try to give the answer. Okay, ready? Human beings' excretory product is the urea. Known by you, na? In human beings, what is the excretory product? Urea. My question is, filtration of urea from kidney, where the synthesis of urea takes place? Anyone will give the answer. Where the synthesis of urea takes place? Where the synthesis of urea takes place? Yes, Venkata, you have given the correct answer. The synthesis of urea takes place in the liver. Synthesis of urea takes place in the liver. That is urea synthesis. There is one cycle that is known as the ornithine cycle. Clear? So when you will come here, we will discuss in detail about the urine formation, about all that fun. Now, I think you know about the kidney transplantation. Kidney transplantation, when we are going for kidney transplantation? Anyone will say, when we are going for kidney transplantation? When the kidney of a person is not functioning properly, we are going to for kidney transplantation. I will say you one very interesting fact about the kidney transplantation. Whenever the two kidneys of a function are not functioning properly, we are taking the kidney of one healthy person. So say me the answer of one question, a person who went for kidney transplantation, how many kidneys are present in the body of that person? Anyone will give the answer of this question, because this is one interesting question. How many kidneys are present after transplantation? How many kidneys are present after transplantation? 2 or 3 or 1 only? Yes. So many of you writing the correct answer. After transplantation, that person is having the 3 kidneys. We are implanting only one healthy kidney, but we are not removing the old kidneys, because old kidneys, they are not harming us. And if you will removing 2 old kidneys, you have to do 2 more surgery. So just to avoid more and more surgery, we are implanting 1. So after transplantation, a person is having 3, but out of these 3, only 1 is functional. Remaining 2 are non-functional. So this is one very interesting fact that you should know, that after transplantation, yes, end stage of renal diseases, Manisha, we are using the transplantation. And I said, after transplantation, a person is having how many kidneys? 3. But how many functional kidneys? 1. How many functional kidneys? 1. How many functional kidneys? 1. This process is known as the hemodialysis. Dikshita has written hemodialysis is different. Hemodialysis means initially when we are trying to remove the urea from our body. But when that process is not sufficient, we are going for 1. That is known as the kidney transplantation. Okay, so this is the one. After listening the lecture, you are running towards your kitchen. So you have to perform one thing, that is the movement and locomotion. Like you are observing one movie and you are having popcorn. So you have to take the popcorn and you have to keep it. You have to push it up to your mouth. Then only it will come. Like you want to drink water, you will move your hand. So without the one topic, that is the movement and locomotion, nothing is possible. So there are two terms. One is the movement and one is locomotion. So see towards me. See towards me. When I am doing like this, when I am doing like this by standing on one place, what I am doing? I am doing movement or I am doing the locomotion. When I am doing like this, what I am doing? I am standing at my one place. Yes, Jaya Charan. Yes, you are absolutely correct. When I did like this, it is the movement. Movement means there is no change in the position. There is no change in the position like trees. Movement. Okay. It is not happening. One tree yesterday, it was in your garden. Today it came to my garden. Never listen na. So plants are showing only the movement. But like if I will do like this, what I am doing? I am changing my position. What is this movement? What is this movement? This is the locomotion. So locomotion means change in the position. And movement means no change in the position. Are you getting the difference? I have shown with the demonstration also. What is the movement and what is the locomotion? So if I will say me in terms like this, how can you correlate the movement and locomotion? Who will write the quotation? How to write? I will give you the clue. All movements are locomotion or all locomotions are movement. How you will say? How you will say? How you will say? Okay. Just say me how you will say correlate the locomotion and movement. All locomotions are movement. Yes, Tanmaya, very good. All, please focus it. Anyone will give the correct answer? Anyone will give the correct answer? Are you getting what is movement and locomotion? If I will say all locomotions are movement, but all movements are not locomotion. Neela Bani, you have given the correct answer. So many of you, Yaswant, you have also given the correct answer. So this is the one. Now, in the movement and locomotion, okay, just I will say very interesting fact. Just here, this is known by you. This is known by you. Known na? So what is your opinion? How many bones are present in human body? Very interesting. Today I am touching all the points of human physiology. When you will come to our college, I will say about all. How many bones are present in human body? Known by you. Yes, Nikhil. Very good. 206 bones are present in human body. 206 bones are present in human body. Yaswant, you added how many days? You replied how many days in a year? No, beta. I asked question like this. How many bones in human body? So 206 bones are present in human body. This is the one point you have to keep in mind. Now, this is our vertebral column. And this vertebral column, I think you have listened one point. Sometimes people are saying that I got the cervical spondylosis. It means problem related with the neck region. Okay, problem related with the neck region. So there are 5 types of our vertebral column, 5 parts: cervical, thoracic, lumbar, sacral, coccyx. So we are having the vertebra. That is why we are included in the vertebrata. We are included in the vertebrata. So many structures which are formed by the bones, like the sternum, like the vertebral column, like the skull, cranium, and all. Okay, like if I will say, I think you have listened the name femur, patella, tibia, fibula. So many things are there. Time is passing very fast. 50 minutes past, 45 minutes past, and still I am interested to teach you. And still no one is saying, sir, finish the class. So you all are good because no one said, sir, finish the class. It means you are also enjoying the class. So two requests. One request, fill the form as early as possible. And second request, whenever come to our campus, please inform us. Please meet to me once. Okay? Because my part is finished. Human physiology is not like this. We have to discuss in detail. Here I have shown only the trailer now. Trailer, the duration of trailer is 1 minute now. The entire movie of 3 hours now. So that is one different thing. So we will meet again. Thank you. Thank you very much. Thank you. Thank you. Thank you. Okay. Thank you.